Set and Venn diagram. Now, you need to understand the most important thing in sets. To understand set is basically collection of data represented in curly brackets. This will be your curly bracket. Now, set are always taken out from universal set. Sets are basically taken out from universal set. Universal set is the main set. Universal set is the main set because all the sets which you will be taking out will be from this universal set. All the set that you'll be taking out will be from the universal set. Now, understanding the sets symbols. Set symbols are, this will become your the sets of, which mean curly set, that you need to make sure that the set will be represented by that particular value will be from the curly bracket. Then we have is universal set, which means belongs to. All the sets will belong to the universal set. All the set will belong to the universal set. If we say not part of universal set, this will represent not part of universal set. O, and that is slash, this will represent null or empty set. This will represent null or empty set. Then you will have this sign. This will represent union. Your union will be represented. Then we have closer to n sign. This is your intersection. Intersection between two sets or more. Then you have this represents subset. Set within a set. If subset is cancelled out, this will represent not a subset. Not a subset. If any set is represented by n, so that means number of values in that set. Any set is represented by n it will represent number of values in that particular set. If it is A dash, it is a complement set. It is a complement set. Now, considering all this, you should be able to know, or you should be knowing that what is basically a universal set. Now, universal set, as we know, is represented by E, right? So, a universal set is one which contains total number of elements, total number of element. It contains all elements for a particular question. Now, as I said earlier, that I normally consider this as main set, because from this set the other sets are created. So if you have value in the universal set, then only you will have value in the normal set. If you do not have value in the universal set, then you will not have the value in the normal set. Then you have is finite set. There are finite or limited number of elements which have limit, elements that are through the universal set. Example, any values from 1, 2, 3, 4, and it will have a limit till, let's say, 10. Then we have is, which you should be knowing, is infinite set, which contain infinite number of elements. Number of elements. Now let's say the question clearly identifies it as even number. Even number is very open, which means it will start with 2, 4, 6, 8, 10, 12, 14, and it will move on, go till any value that you have. Or let's say prime number, all prime numbers. All prime number. Then all the prime number will be represented through what? All the prime numbers can be represented through 2, 3, 5, 7. Then we have is 11, and it will move on and on and on. So that is what? Your infinite set. With this respect, we also have what? Equal set. What does the equal set represent? Equal set represents sets that are considered to be equal if they are exactly same elements. Same elements, sets are equal sets. Same element sets are equal set. Then we have is a null set. All null sets are empty sets. Empty sets are represented by this. It does not contain any element. It does not contain any element, I would say, from the universal set. From the universal set. Then we have is a subset. A subset is a subset is divided into two categories. Proper subset and finite subset. If every element of a set B is also an element of set A. If every element of set B is also an element of set A, while set A contain some other elements too, then B is a finite subset of A and is written as B is subset of A. B is subset of A. Whereas if B contains some elements of A, but B is not equal to A, then B is called a proper subset of A and is written as B is subset of A. Now, this is very important part of subset recognition, which clearly means element of set A, if every element of set B, every element of set B is also an element of set A, that means every element of set B is also an element of set A, while set A contains some of the element to then B, that means it is a finite set of subset A and is written as B is the subset of A. This represents the finite set. Whereas if B contains some element of A, B contains some element of A, but B is not equal to A. That means B is not equal to A. That means A has more elements in it. Then B is called a proper set of A and written as what? B is the subset of A. Similarly, then what do we have is intersection. Intersection is basically represented by N. Intersection is when two or more sets have common values, or I would say common elements. It is your intersection set. That means any set has common values or elements. If set A is represented by 2, 3, 4, 5, and set B is represented by 3, 5, 7, 9. So, if I want to have A intersection B, my set will become only 3 is common and 5 is common. 3 is common and 5 is common. So that means 3 and 5 will become the intersection set. In the same example, if we just consider union, union means all elements of set. Union means all elements of sets, which clearly identify as, let's say, A is 2, 3, 4, 5, and B is 3, 5, 7, 9. So the answer for A union B will be 2, 3, 4, 5, 7, 9. That means all the values will be written. If they are repeated, it will be written once. So union means writing down all the elements of the set. Intersection means only the common values will be taken into consideration. Then what do we have? We have complement set. Complement set, as I said, your main set is universal set, and if any set is given with value, with elements, let's say your universal set is 1, 2, 3, 4, 5, 6, and your set A has values of 3, 4, and 6. Then your complement set will be all the other values than the normal set. That means your normal set is 3, 4, 6. What will be the other values from the universal set other than the normal set? That will be 1, 2, and 5. So your complement set contains all the other values than the normal set from the universal set. Your complement set contains all the other values than your normal set from the universal set. If I would have said that B is from this universal set 2, 3, 4, 5, then B complement would have been 1 and 6. 2, 3, 4, 5, then B complement will be 1 and 6. Then what do we have? We have disjoint set. We have disjoint set. Disjoint set has no common elements. Disjoint sets have no common elements. That means there is no intersection between the sets. There is no intersection between the set. That means A intersection B will not be possible, which means it will give you a null set, an empty set. Now, see, the most important part is what to do in the question or how will be the question asked. Now, this entire thing was basically what are the notations, what actually the things that are involved in the set are defined as. But let's just say important concept starts now. Important concept starts now. Which means that let's say, as I said, your universal set is the main set. Your universal set is the main set. And I would rank my universal set as, let's say, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Just to make sure that we have the universal set values. What can be asked in the question? What can be asked in the question? The question can be asked that we have set A, and set A, the examiner will tell you, is an even set. Set A contains all the values of the even numbers. So, the even numbers will be from where? From the, this even numbers will be from the universal set. You will not be taking any other values which is not the part of universal. Only the values that are part of universal set will be the part of the normal set. So that means even number from the universal set. We have 4, 6, 8, 10, and 12. So what are your even numbers? This will be 4, 6, 8, 10, and 12. So this will become your, this will become what? Your even set. Now, in this particular concept, let's say you will be asked your odd set. Now, what will be your odd set? 3, 5, 7, 9, 11. So, this will become your odd set. Then the examiner can ask you your prime number set. What are prime number? Prime numbers are those that are divisible by their own number and by 1. So 3 is prime number, 2 is prime number as well. So 3, we have 5, we have 7. Then we have 8 is not a prime number, 9 is not a prime number, 10 is not a prime number. Then we have is 11. Then the question can also refer to factors or of 24 or factor of 12, let's say. Now, factor of 12, what does that mean? That means any number that is divisible by 12 will be, or the 12 comes in which table? 3, 4, 6, and 12 itself. Then E multiple of 4. That means 4 table, 4, 8, 12. So these are the normal set that the examiner will ask you to be defined through what? Your A, B, C, D, E. And all the values that we have written down, we have written down from the universal set. Your F set can be, your F set can be X is greater than equal to 8. So the values will be 8, 9, 10, 11, and 12. Because your universal set contains value till 12. And if this would have been X is greater than 8, then we would have started from 9, 10, 11, and 12. So these would have been the values from the set. Now, the most important part that you need to understand is that let's just take A. A has 4, 6, 8, 10, and 12. Because A was your even set. A was your even set. We are continuing the question of what we did. So, just referring back to the value that we have taken from here. Your A was your even number. I've written down this. These even number came from what? These even number came from the universal set. Now, if the question would have asked that what is NA? What is NA? So we will be counting down the numbers 1, 2, 3, 4, 5. So that means how many numbers are there in the set? 1, 2, 3, 4, and 5. So there are 5 numbers. If the question would have said PA, which means the question wants the probability of set A. So how many numbers? 1, 2, 3, 4, 5. 5 numbers. Out of how many numbers from the universal set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10 numbers from the universal set. So we will be writing now 5 upon 10, which is what? 1 upon 2. So probability will always be your event upon the total number. But if the question would have asked, to write down a complement, So if all the even numbers are there, other than the even numbers, your a complement set would be 3, 5, 7, 9, 9, 11. So this will become your A complement 3, 5, 7, 9, and 11. That means your B set B is equal to A complement. Your set B is equal to A complement, which is defined as what? Equal sets. Which is defined as what? Equal set. So your A complement will be 3, 5, 7, 9, and 11. Similarly, what we understand this is that if I want probability of A complement, so you will have to find out what? N of A upon N of universal, which means 5 upon 10 again, which is again 1 upon 2. Because 5 numbers were even and 5 numbers were odd. So P complement becomes 5 upon 10, which is 1 upon 2. So let's just refresh a bit of concept and then we can move forward towards the union and the intersection. So that means the examiner will give you a universal set. The examiner can ask you N, which is the number. The examiner can ask you P, which is the probability. The examiner can ask you to find out set A, set B, set C with the given information from the set which you will be taking out from the universal set. So N and P are important plus sets are important. So let's just work through. Let's take the two sets which we already took out. Let's say your factors of 12, 3, 4, 6, 12, and multiple of 4, which is 4, 8, and 12, right? So factor of 12, we had 3, 4, 6, and 12. Then we had multiple of 4, which was 4, 8, and 12, right? So these were the normal questions, factors 3, 4, 6, 12, and 4, 8, and 12. And I would represent them as D and E, set D and set E. So let's just work on these two sets together. If I say ND, ND will be, since D has 3, 4, 6, and 12. So ND is 4 numbers in the set. If I say PD, PD will be 4 upon 10. And where did this 10 come from? 10 is the number of the universal set, which was 10. Initially, we calculated out. This was your E, and we counted it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will give me what? E, number of universal set, which is equal to what? 10. So every time when you take out the probability, you will be dividing it with the total number. That means NPD will be 4 upon 10. With the same concept, the question from for E is 4, 8, and 12. So NE will be 3 and PE will be 3 upon 10. So probability of 3, E will be 3 upon 10. Now let's just work upon D complement. D complement. So if I just look at the universal set, your universal set started with the number 3 till 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And if you see, your D was 3. So let's just cancel 3. Let's just cancel 4. Let's just cancel 6. And let's just cancel 12. So what are the other numbers that are left? The other numbers that are left are 5, 7, 8, 9, 10, and 11. So this will become your D complement. All the other values from the universal set which are not part of the normal set. So D was what? 3, 4, 6, and 12. Let me just erase this. 3, 4, 6, and 4, 6, and 12. So we cancelled out 3, 4, 6, and 12 from the universal set to get what? D complement. Now, if I want to have ND complement, so 1, 2, 3, 4, 5, 6. How many numbers do we have? 6. If we want to have PD complement, this would be 6 upon 10. You can always simplify this. This will be 3 upon 5. Similarly, if I want to have E complement, then to find out E complement, your E number were 4, 8, and 10. So that means remaining will be 3, 5, 6, 7, 9, 10, 11. So your N E complement will be 7. Your P E complement will be 7 upon 10. 7 upon 10. Now, with the same data response that we had, since we have E and D, or D and E, let's say D was 3, 4, 6 and 12. And E was 4, 8 and 12. The question says D intersection E. The question says D intersection E, which means what? Common values. Why? Because this sign represents the intersection sign. This sign represents the intersection sign. Intersection sign means the common values. Common values between D and E. So if we just look at the common values, the only common value that we have is 4 between and 12. We have 4 and we have 12. So that means specifically means that D intersection E is equal to 4 and 12. So if the question would have been ND intersection E, we would have written it as 2. How many numbers? 2. If we had probability D intersection E, this would have been 2 upon 10, which will be 1 upon 5. Why 10? Because the formula for this will be N D intersection E upon total number of universal set. Similarly, with the same example, we could have also written the question can be based upon D intersection E complement. The question can be D intersection E complement. So other than 4 and 12, all the numbers from the universal set can be taken into consideration. 3, 5, 6, 7, 8, 9, 10, and 11. How many total in numbers? That means N D intersection E complement will be 8, and probability D intersection E will be complement will be 8 upon 10. So this is normal for the intersection where we will be taking out the common values between the two or more sets. Similarly, with the same concept of D and E, your D was 3, 4, 6 and 12. Your E was 4, 8 and 12. The question says you need to find D union E. Now what does union mean? Union mean common numbers. Oh, sorry, I will correct it. Union means all numbers. All numbers to be taken. So what does all number mean? 3, 4, 6, 8 and 12. 3, 4, 6, 8 and 12 will be the all the numbers from D and E. Common numbers will be written only once. If it is D union E and we are taking N. So how many N numbers are there? 1, 2, 3, 4, 5. If we want to have probability of D union E, it would be 5 upon 10. So if we want to have D union E complement, so complement would have been 5, 7, 9, 10 and 11. And if we write down D union E complement N, so again it is 5. Probability of D union E complement will be 5 upon 10. So this should be what 1 upon 2. So this is the normal union of whatever can be represented through the question. Sometimes the set can be differed as well. Let's just say, let's take down the example of the set that we took, the smaller set, or just writing down another example of the set because some questions are normally referred to this. If I say a Z set has a value -1, 0, 1 and 2, And the question says that there's a set X which is element of Z square, which is element of what? Z square. Then I need to write down the values of the element of the X. So if the elements are of Z square, so what I need to do is to find out X, I will be squaring all the elements of what? Z. I'll be squaring down all the elements of, so which means this will be 1, 0, 1 and 4. Now you need to understand this, that your 1 is written twice, because negative 1 square is 1, positive 1 square is 1. So the answer will be 0, 1 and 4. The answer for this will be, because sometimes the question can ask you nx. So the answer would be what? 3. So this is the normal example of such, that there can be the examiner testing you with the square of the other factors or other subset or other factors that are given, or I would say other sets that are given. The examiner can tell you to find out the square of the other set. So here's the example from the past paper question, which represents the variables or the universal set as A, B, C, D, E, F, G. Your P is A, B, C. Your Q is B, C, D, E, F. The question says P union Q. The question clearly says P union Q. To have P union Q, that means all the element of P and all the elements of Q. So P union Q will be A, B, C, D, E, and F. All the elements of B and P and all the elements of Q, but you needed N, right? So that means you need to count the numbers that are in the set. So 1, 2, 3, 4, 5, 6. How many numbers do we have? We have 6 numbers. So we write this thing down as what? We write this thing down as 6. So there are 6 numbers. So let's just write down 6 here. Then the question says, let the member of the subset P complement intersection Q. So first of all, we need to find out P complement. All the values which are not in P but which are in P, we need to write down P complement. So that means all the other values other than the P set from the universal set. So ABC, we'll write down D, E, F, G, and H. Right? So P complement is D, E, F, G, and H. And Q is B, C, D, E, and F. What does intersection means? Intersection means common numbers. Intersection means common numbers of variables. So the common is between the two is E, that we can see. We can see D and E are the common number, and we can also see F. So Q has F, P complement as has F as well. So what do we write down? We need to write down the members. So D, E, and F are the members of the P complement intersection Q. So here's another example question. Let's say P is 1, 4, Q is -1, 1 and 2. X, Y, X is element of P and Y is element of Q. So first of all, P union Q. For this, what we need to understand is P union Q means all the values of P and all the values of Q minus 1, 1, 2, and 4. So NP union Q should be 4. Now list the members of R. Your R is X upon Y, and X is element of P and Y is element of Q. Now you need to understand that P is 1 and 4 and Q is minus 1, 1 and 2. Now you need to make sure that you create set because X is P and Y is Q. With P, which is X, with P, which is X, you can use minus 1 as Q. With P, X, you can use 1 as Q. With P, X, you can use 2 as Q. With P4, you can use minus 1 SQ. With P4, you can use 1 SQ. With P4, you can use 2 SQ. That means there would be 6 different members or 6 different ways to calculate this. So what will be the coordinate? 1 and minus 1, 1 and 1, 1 and 2. You can also have 1 and minus 1 or 4 and minus 1, 4 and 1 and 4 and 2. These will be the 6 coordinates used to take out the value of R. Let's say we are using the first one. So this would be 1 upon minus 1. So R is what? Minus 1. Then the second one would be 1 upon 1, which means 1. The third will be 1 upon 2, which is 1 upon 2. The fourth one will be 4 upon minus 1, so this should be minus 4. Then the fifth should be 4 upon 1, which is 4. And the last one should be 4 upon 2, which is 2. So all the members of R should be starting from the least, which will be minus 1. Then we will write down as, which will be minus 4, minus 1, 1 upon 2. Then we write down 1, then we write down 2, and then we write down 4. And if the question would have been saying that NR, then the answer would have been 6. So the element will depend upon the equation which is there. So this will be necessary for you to understand that such question will be given as X and Y, whereas they'll tell you that X is element of P and Y is element of Q, and then you will have to make sure that the coordinates are used. Similarly, another type of example that can be tested in the past papers can be, let's say, that you need to find out Z, and Z could have been 2x plus y. Z could have been 2x plus y. If Z is 2x plus y, then all the 6 coordinates that we took out, what were those? 1 minus 1, 1, 1, 1, 2, 4 minus 1, 4, 1, 4, 2. Each coordinate will be substituted to find out the value of Z, which means, let's say, Z is 2, 1 and minus 1. So Z will become what? 1. Similarly, since Z is 2x plus y, the other coordinate is 1 and 1. So 1 plus 1 will become what? 3. Then again Z, 2x plus y, Z, 2, 1 plus 2. So this should be what? 4. So 1, 3, 4 are the 3 coordinates using the 3 other coordinates. Now Z, 2x plus y. So this should be 2, 4 minus 1. This should be 7. If it was Z, 2x plus y, then we could have been writing down 2, 4 plus 1. This is what? 9. And finally Z, 2, 4 plus 2. So this should be what? 10. So how many different elements of Z are there? 10, 7, 9, 4, 3, 1. So 6 answers because there were 6 different options using your what? X and Y, because X is represented by P and Y is represented by Q. So P is 1, 4 and Q is what -1, 1 and 2. The question did not make any specific point that this value will be taken. So you will be taking down all the values 1 and -1, 1 and 1, 1, 1 and 2, then 4 and -1, then 4 and 1, then 4 and 2. Then these all elements will be taken into consideration. Such questions are tested in your past papers. So this is very important. So that's about it. Thank you very much.